Welcome to Koinos Koncepts. This is a short mini-series of presentations designed to give a brief but detailed introduction to the Koinos blockchain. Part 3, Microservices in Koinos. So microservice architecture is not specifically designed for blockchain. Instead, it's an existing design concept that's already employed by many software design teams all around the world. It's a well-tested design method, and Koinos is the first blockchain to apply this design methodology. There are some important features that microservices provide. First is that it allows for small groups to work on parts of the blockchain. It allows for autonomous development of the individual microservices. In the future, this helps decentralize future upgrades instead of relying on the core team. If someone wants to improve a microservice, they don't have to understand the entire blockchain. Rather, they only need to understand how that specific microservice that they want to upgrade actually has to work. Microservice architecture also allows for a continuous delivery of the development of the blockchain over time, rather than having it all completed at once. Now, each microservice has a different resource utilization, and it can be independently scaled. This equates to having an efficient use of CPU and memory resources. So on this slide here, we have a diagram that shows how scaling a blockchain actually can work. So on this diagram, I have shown an XYZ kind of three-dimensional scaling of a blockchain. On the x-axis, we have horizontal scaling by simply adding more power to the actual node itself. This means having a more efficient, more powerful CPU and more memory for all of the node operators. On the y-axis, we look at scaling a blockchain by reducing the size of the information going to each block. Typically, you see this as layer 2s, where a lot of the transactions occur on layer 2, and they're only settled on the layer 1 blockchain. Lastly, if you want to actually make a blockchain perform better, you can actually functionally decompose the blockchain into its core functions, and this is what essentially microservices does. Now, once you decide to employ a microservice architecture, you have to look at nodes as clusters of microservices that act together. So a Koinos cluster is a set of microservices operating together. The microservices function as a hub and spoke model. So in this diagram, we see the 7 microservices that creates a Koinos cluster. Each of these services are connected with a communication protocol called AMQP, or the Advanced Messaging Queue Protocol. Microservices represent a core service that provides the functionality of a blockchain. The Koinos engineers' experience in building the blockchain has led to these 7 main microservices: the Koinos chain, Koinos block store, the Koinos mempool, the Koinos P2P, Koinos block producer, JSON RPC, and the transaction store. So the Koinos transaction store, JSON RPC, and the P2P microservice are all written in Golang. The transaction store basically archives transactions that have been included into a new block. It acts as a historical reference used to answer queries by the JSON RPC microservice. The JSON RPC microservice itself receives and translates requests, then it directs them to the correct microservice. The peer-to-peer microservice helps new node clusters get synced up to the head block. Once synced, the peer-to-peer microservice is responsible for gossiping new blocks and transactions between each node. The Koinos block store is written in Golang, and the Koinos mempool microservice is written in C++. The block store contains all of the blocks that a new node requires in order to construct and sync up their chain. It also includes new blocks that are to be added to the Koinos chain. The mempool contains all the user-submitted transactions that have not yet been written to the block. The Koinos block producer and the Koinos chain microservice are all written in C++. The block producer microservice produces the actual blocks based on the transactions located in the mempool microservice. The Koinos chain is the actual blockchain itself. It is constructed with all the blocks located in the block store microservice, and this microservice maintains the state of the chain. All of these microservices should contain components of a blockchain that you may be already familiar with. They are just functionally decomposing them into core services that have very limited function, but when put together, the core microservices provide the functionality of a basic blockchain. Now, some other important features of a microservice architecture is that it allows microservices to be created by a user. A custom microservice can be created by any user. All custom microservices have first-class citizenship and share the exact same capabilities as the core microservices, which means that you as a user can create custom block producer, custom mempools, and many more. Another important thing is that because of the AMQP messaging service, you no longer need to poll the blockchain and provide parallel data storages like Ethereum, which is basically how a push and pull request works. And this is because Koinos is an event-driven system. So here's an example of a microservice flow. The Koinos chain microservice has announced that a block has been accepted. The messaging queue receives this information, and it begins to broadcast that information to the correct microservices that needs to know that piece of information. Once the Koinos block store knows that the block has been accepted, it can store that block so that other nodes can use that block to build their own chain and sync up. The Koinos transaction store will archive this block, and it will allow the answer of queries by other nodes on whether or not this block was accepted. The P2P microservice now knows that a new block has been accepted and begins coordinating with other nodes. Lastly, once the Koinos mempool knows a block has been accepted, it can remove all the transactions that were in that block from the mempool. And that's basically how the microservices communicate with each other and how information is spread from one microservice to another. What you will notice is that each of these microservices operate independently of each other, and it relies on the messaging protocol in order to get the information it needs and also to spread the information that it produces to other microservices. If you want to learn more about the Koinos blockchain, visit koinosforum.com for more information. Each of these videos are designed to be 2 to 10 minutes long, and they focus on the big ideas of Koinos.